Hello there, ROS developers, and welcome to this new live class where we are going to be talking about ROS2. Specifically, we are going to be seeing actions, ROS2 actions with C++. So let's go for it. Alright, so hello there, welcome everybody. As I was just saying, in today's live class we are going to be talking about ROS2 again. We are going to be working and programming using C++. In this case, we are going to be checking ROS2 actions. So yeah, first of all, before starting, as always, let me check and verify that everything is working as expected. So let me know please here in the chat if everything is going okay, video is fine. Audio is fine. Let me know here so that I can keep going without worrying about anything. Let me say hello to, I can see here we have Der Capute. Hello also to Engineering Nations. You are two war veterans, you too. Lakshmi, Kamran, Viana, I can see Ricardo also is here. Everything is fine, says Engineering Nations, also Viana. Okay, excellent, then let's go for it. So, today, as I am doing in the last classes, I'm going to go step by step. We have some new features for live class that I'm sure that you are going to love. So I'm going to do everything slowly, step by step, so that all of you get the idea of how everything works. I know that some of you are already veterans, you have been in many live classes and you already know how to move fast in all the setup of the live class, but for the people who is new, I want to make everything clear and to explain everything so that we have everybody in the same page and nobody gets lost in the process, which is something that I don't want, because I want to teach and to make all of you learn there. So great, let's go for it. So let's not lose any more time here in the introduction and let's go for it. Then, as always, we are going to be working in our platform in the construct. So I'm going to switch right now to my computer screen. There we go. So right now I'm here in the construct. In fact, let me log out here. So for the ones who are new, in the last live classes we've had some people which was telling me that it was his first live class. So let me know also in the chat, by the way, if this is your first live class, if second one, third one, your 100, which is possible since we have already surpassed the 100th live class mark. So yeah, for the ones who are new here, this is the construct, this is the platform where we are going to be working, where we are going to be doing this live class. So in case you already have an account, you just have to enter here your credentials and log in. In case you don't have an account, you can sign up here. It's going to be free. It's going to take you just a few seconds, so go for it. And then we are going to log in. Okay, then once you are logged in the platform, we are going to come to the left menu here, which is going to open as we pass the mouse close to it. And here we have different sub-menus, as you can see. And the one we are interested right now in this case is live classes. All right. So if we click here on the live classes, sub-menus, as you can see, I'm going to mute myself here. You have access directly here to the live class that is occurring right now. Yeah, so this is right now, this is the live class that I am doing, so I am seeing it live here. Then, the idea here is that all of you can get the ROSject directly by clicking in this button here, which says fork and open the class ROSject. So, right now I want you to click here in this button, fork and open the class ROSject, and this is automatically going to copy the ROSject to your workspace and is going to open it. automatically. Okay, I'm not going to do it because I have my own project. But all of you, I want you to click right now in this button here in order to fork to your workspace the project and to open it automatically. All right, then I'm going to open it from the My Project section, because actually this is a project that I have created myself, so I don't need to fork it or anything, because this is the original project, which is mine. And by clicking on this button, I have just shown to you, by clicking on this button and forking the class project, actually what you are going to do is to get a copy of this project that I have created in your workspace. Yeah, makes sense? Then I'm going to actually open it as a regular project by clicking here in the Run button, and this is going to start loading the live class project. As you can see, automatically it has also opened here a small window in the bottom right corner with the live class. Okay, so this is a new feature that we already tested in last week live class, so that you can see the live class content while you have also the project opened. So this is something that we wanted to introduce for many weeks, because it's usually a little bit cumbersome if you have to be working in the project in one page, then you have the live class video in another page, and then if you want to comment you have to go to one and then go back to the project, and it's a little bit cumbersome in some cases. So we wanted to put everything into one single place, so that it's much more easier for you to follow the live class while you are working in the project and testing things. All right, so as you can see right now, I have here the project opened with the notebook, which has opened automatically, as you can see, and I can visualize here the live class at the same time as I am checking the project, or I am executing commands, creating scripts, whatever. Okay, so we already introduced this feature in last week's live class, so probably some of you have already seen it. For the ones who don't know it, here you have it. But we have gone a step further for this week, and we have added also the chat. So you can, by the way, you can click here in case you don't like to have this small window here with the live class. You can always click here and it's going to open in a different tab, okay, as it is as it has worked always. Okay, in my case I'm going to close this, and also we have here, as you can see, the show video and live chat button. So if I click in this button here, I'm going to be able to visualize the live class, and I'm going to have also the chat open. So I'm going to be able to visualize here the live class. You are going to be able to see what I am doing in the live streaming, and you are going to be able to comment whatever you want here, so that in case you have any doubt forever, let me send a message, by the way. Hey teacher, you look very handsome today. There we go. Okay, so this is the idea. The idea basically, jokes aside, the idea is that basically you're going to have everything in one single page. Okay, so you are going to have the live video, the live streaming, you have the chat in case you want to post any doubt, and you have here the project in order to work. All right, so here I do agree, says Ricardo. Thank you very much for lying. Thank you very much for lying to me. Okay, so let's go for it. Then once I have introduced the new environment, I hope you like this new way of working. I think it's going to help a lot, so that all of you can practice, because it's our focus. My focus is to make you practice. I don't want you to be there in your computer just listening and watching to what I am seeing, but I want you to be practicing with me. So meanwhile you are listening or watching to the live class, you are practicing and you are executing the commands that I am going to be executing. You create the programs, you test them, etc., etc. Okay, then Okay, so once I have introduced all this, it's time to go for it. Let's go to work. Then I'm going to make the notebook a little bit bigger. So as I was saying, today we are going to be talking about the action server in C++. So some requirements in order to follow this live class are, as always, you have to have a basic knowledge of Linux. Here I have left a link which you can click here, and this is going to take you to our free Linux for Robotics course, which you can check right now for free in case you want to improve your Linux skills. So here you have a free course where you can get them and test them. Also, of course, since we are going to be working in C++ in this case, I have left also the link here to the C++ Basics course, which is, by the way, also free, and it's new. This course has been introduced recently, so you can have a look also to it. It's completely free also to test, so you can complete it for free, and it's going to basically give you some basic skills of C++ programming that you are going to need, yes or yes, if you want to work in robotics development. Okay, so it's going to explain you from the basic to some more advanced skills like object-oriented programming, pointers, etc., etc. Okay, very interesting course, so I really encourage you to have a look at it. And finally, we have the ROS2 Basics in C++ course. This one, it's not free, but you can check it also if you are interested in it. And basically, it's going to teach you ROS2 basic concepts based in this case or in the C++ code. Yeah. So this course is going to be updated this week with new features. For instance, we are going to introduce actions, which is today's topic. We are going to introduce actions to this course, and we are going to introduce also node composition. So we are going to have a brand new course. Basically, it's going to be almost brand new for this week. So yeah, I really encourage you to check it. As you can see, it's also working in ROS2 Foxy, as our ROSject, by the way, is also based in ROS2 Foxy, which is the latest stable distribution for ROS2. So yeah, here you are going to be able to learn all the basic concepts of ROS2, not only actions, but also services, topics, message creation, many things. So yeah, go for it. And by the way, let me tell you also that we are starting to work, it's more accurate to say that, we are starting to work on the ROS2 Basics for Python also. So it's going to be available in following months. I don't have an exact date yet, but I want to tell you that we are already starting to work on this ROS2 Basics for Python. All right? Okay, so let me close all this and let's go for today's topic, which is our live class and talking about ROS2 Action Server in C++. Then, first step to do here is to launch our simulation. Okay, then let me have a look here at the comments. Albert, I can see Engineering Nations who says that my voice is echoing a lot. Ah, okay, yeah. He had two streams running on your end. Okay, yeah. This was happening. Well, sometimes when I open these streams. This stream here, live stream, if I have the sound here, I am listening to myself also, so it's possible to I am muting it here, so maybe this could be also affecting sometimes. In any case, I'm always muting this, because otherwise it will be kind of confusing. Still loading, says Viana F. What it is still loading? The ROSject? You are not yet in this page here. Let me know here in the chat if you are in this page with the ROSject loaded or not. What I'm going to be doing right now, by the way, is to load the simulation. I want to start loading the simulation. So, in order to do that, first of all, is to open a web shell, of course. Then, here in the bottom left menu, we have all the options that we can launch here in the ROS DS environment. So first of all, I'm going to open a new web shell. and I'm going to execute here these commands. First of all, I'm going to source the ROS2 version, which I want to work with, which is Foxy. So let me copy and paste the command directly here. I'm going to source next the simulation workspace. I'm going to again copy and paste it directly here. Paste. I recommend to use the shortcuts Ctrl+C, Ctrl+V in order to speed up all these copy and pasted commands. So yeah, I have sourced the ROS2 version I want to work with, which is ROS2 Foxy. I have sourced the simulation workspace, which is the workspace where I have placed all the simulation and gazebo related packages. You can have a look at this workspace in the graphical tools, by the way. So I'm going to open it right now. In fact, let me open the code editor here. It's the second icon next to the web shells. This is going to open basically the IDE, the integrated development environment, which is going to allow you to visualize all the files and everything in a graphical way, which is always much more user-friendly. And here you can see the different workspaces available. In this case, we have sourced the simulation workspace, which is the workspace here, if you go into it, which contains the T3 Foxy repository, which contains all the Turtlebot 3 simulation related packages. Okay? I'm not going to go into details on this. You can check them if you want on your own. And then finally, what I'm going to do is to execute this script, startsim.sh. Then this script, start_sim.sh, you can find it as well here in the T3 Foxy repository. As you can see, we have different sh scripts in order to launch different simulations. In this case, the one we are using is the startsim, which is this one, the last one here. So if you open this script, you can see here its content in the IDE. So basically what we are doing here is just we are sourcing some gazebo related files. We are also setting some gazebo related environment variables. As you can see, this gazebo resource path, gazebo model path, and the Turtlebot 3 model. And finally, we are just executing a simple ROS2 launch command, which is basically going to start my gazebo simulation. Okay, so in order to execute this script, startsim, I need to come to this T3 Foxy folder. So let me do this right now here. So cd simulation workspace src T3 Foxy. Okay, so now if I do an ls, I'm going to see here all the contents, and I can see here my startsim.sh script. So I can now run this last command, which is going to start my simulation. There we go. Okay. So now I have started my command in order to launch the simulation. So the final step here is to actually visualize the simulation. So visualize the client, which we can do here by directly clicking on this cube icon. Let me do it. This is going to open here a window where I'm going to be able to visualize gazebo. There we go. And here I can see my gazebo simulation with an empty world in this case, and here in the center of the simulation, the center of the world, I have the Turtlebot 3 waffle robot. Okay? Excellent. Okay, so in my case, here I have done all the steps in order to have everything properly set up for the live class. So I have finished my setup. Then let me have a quick look at the chat to see how all of you are doing. The ROSjet is still loading. Just finished loading the ROSjet. Loaded successfully. Okay. Can you give the link? Is asking MD Nihal. We are not working with the link anymore, Nihal. So if you want to enter into today's live class, I'm going to repeat it one more time in case somebody has arrived late. Let me repeat it very fast one more time. You have to come to our main page, to the construct page. Then here in the left menu, you come to the live classes if you click here in live classes, you are going to come, the left menu, you are going to see here the current live class, which is this one, and you have to click here in the fork and open the class project. Then by clicking in this button here, fork and open class project, you are going to automatically get the project for today's live class, and it's going to be automatically opened for you. Okay, so there's no need anymore to share links or anything. You can come directly here to the live classes menu and click on the fork and open class project. All right, let's come back here to the project. Okay, loaded, mine too. The source opt ROS Foxy setup bash is complaining that it was already set up. Yeah, don't worry about that message, Viana. Don't worry. This is normal. It always appears. It's not an error. This is normal. This message. Okay. All right. So what I'm going to do right now is to minimize this shell where I have the simulation running, because I don't want to close it by mistake or anything. So I'm going to just minimize it and forget about it. And I'm going to open a new one, which is where I'm going to start working for the live class. All right. So let me come back here and let me know. So before starting with the live class itself, as you can see here, we have the contents for today's live class. But before starting with the live class itself, let me know if you are in the same point as I am, which means you have opened the project and you have loaded the gazebo simulation with the Tartarbot. You have it here ready to start working with it. So is this your current status? Are you in the same point as I am? I don't want to leave anyone behind, so I would like you to tell me if you are here at the same point as I am. I am at the same point, it's Morat. Great. Same point also for Engineering Nations. Okay, so it looks like everybody is at the same point. Yes, it's also Fred Gomez, also Ricardo. Excellent, excellent. Okay, then let's go for it. Okay, so today we are going to talk about about actions in general, more in particular the action server in ROS2. There are some things which are similar to ROS1. So in case you have already worked with ROS1 and you know what an action server is, what actions are in ROS1, it's okay. It's the general idea, it's pretty similar in ROS2, but there are some particularities. So there are some things which are different between actions in ROS2 and actions in ROS1, in the same way that there are some differences between ROS2 services and ROS1 services. All right, then let's first give a general idea of actions and how actions work, and then after the general idea, we are going to move directly to the practice, which is going to help us to better understand the concepts. Then okay, then yeah, so actions basically are another communication type in ROS2. Well, so you can communicate nodes using topics, using services, and actions is another method of communication between nodes in ROS2. In this case, actions are more intended for long-running tasks. Why? We are going to see it in a moment. Basically, we can divide actions in three parts. One is the goal, second one is the result, and third one is the feedback. Okay? So, actions basically are built on topics and services, and their functionality, so actions are in many ways are very similar to services in the sense that they provide a functionality to other nodes. But there is a main difference, which is, well, there are two main differences in this case. One is the feedback. So actions provide feedback. While the action is doing its functionality, it can send feedback to the client so that you can, for instance, send feedback messages in order to know how the action is going. So let me explain this with an example. So the main example in this case would be navigation. So actions are very useful, for instance, in the case of navigation. Let's imagine that we have a robot and we want to make the robot go to a goal, navigate autonomously to a goal. Then for this scenario, an action would be ideal. Why? Because we would send a goal to our action, which is going to be a position in a map. Let's say, let's imagine our house, and we want to send our robot to the kitchen, let's say, from our room to the kitchen, so that the robot grabs a Coke and takes it to us. So let's imagine this scenario. Then we would send a goal to our robot. Yes, we would send a goal to our robot, which would be, hey, go to the kitchen. Then while our robot is executing this goal, which is going to the kitchen, it can send us back feedback. For instance, telling me, hey, I'm getting closer to the kitchen. Or if something goes wrong, he can say, hey, I got stuck here in the corridor, or whatever. But since achieving this goal is going to take some time, we can use this feedback in order to know how everything is going, for instance, okay? And finally, in case that the robot reaches the goal, which is arrive to the kitchen, it can send a result back to us, telling us that he has arrived successfully to the kitchen. Yeah? Then, here we have a graphic, which right now maybe it's a little bit overwhelming because it has many things, but let's say I'm going to go over it right now, and at the end of the live class we are going to come back here so that we can better understand all of this. Then we have basically the action, which we have here represented in the middle, and then we have one node which is going to be the client, and another node which is going to be the server. So it works in a client-server method, like services do. Okay? Then in this case we have three things, let's say. So we have the goal service client, which is a service, the feedback, and the result. Yeah? So as you can see, we have three groups here, which are the goal, the feedback, and the result for the client, and the goal, the feedback, and the result for the server. Yeah? Then both the goal and result work with services, and as you can see, feedback works with topic. So basically this is a combination of services and topics. This is a different thing, for instance, from ROS1, which everything was working with topics. Yeah. Then we are going to have our client node, which is going to send a goal to our server. Then the goal is going to travel here through the goal service until it reaches the server, the action server in this case. Then the action server is going to do whatever it needs to do, and it's going to keep sending feedback, as you can see here, back to the client. Okay? Then once it finishes, as you can see right now, once the action finishes, it's going to send the result back to the client. Yeah? So you can see here an animation basically with these balls which are moving around here. Okay? But in any case, this is very abstract in my opinion, so the best we can do here is to go to practice. So by practicing, by creating our own action, we are going to see this much more clear. Okay? There's one more thing which I didn't explain here, but besides feedback, another interesting thing about actions is that they are preemptable. What does it mean to preempt an action? That we can cancel them. So we are going to, in order to start an action, we are going to send, as we have said, a goal from the client to the server, Then, while the action server is doing whatever it has to do, its functionality, we can, at any point, we can cancel this action. Okay? Then this is known as preempting the action. Okay? So this is another interesting feature. We are not going to see it in today's live class because it would be too much, but it's good that I introduce it to you so that you know about it. Okay? Then let's keep moving because I'm talking too much and I don't like to talk that much. So let's go actually to practice. Then obviously, if we want to have an action, we have to start by building the server, because the action server is actually the one which is going to provide the functionality to other nodes. From the client, basically, we are only going to call this action server. We are going to call it by sending a goal to it. But the core of the action, let's say, it's always written in the action server. Then we are going to start by writing the server code, the action server code. Then for this, I have here a brand new fresh shell where I'm going to start writing all my commands. Then first of all, I need to prepare it in order to start writing here and executing here ROS2 commands. So let me copy here again the source of the ROS2 Foxy and paste it. There we go. As you can see here, it's telling me also a message, which it's perfectly normal. This is not any error. Don't worry about it. And then I'm going to go to the ROS2 workspace SRC folder. Let me go. CD ROS2 workspace SRC, which is just another workspace that we have here, which is basically, this workspace is intended to place all the ROS2 packages that you create. Okay, this is why I'm going inside this workspace in order to create my package. So actually what I'm going to do right now is to create a ROS2 package. So let me directly copy one more time the command from the notebook to my shell by Control C and Control V here. There we go. Very simple command. As you can see, ROS2 package create. Here I place the name of my package, which is going to be, in this case, my action server. It's going to be a CMake package, so a C++ package, and I am adding here some dependencies that I'll be using, like RCLCPP, RCLCPP action, test action, and geometry messages. Okay, we are going to better understand all this in a moment. Then let me run my command, and I have now created my brand new package, ROS2 package, named my action server. I can see it here, and I can see it also in the graphical tools. My action server, here I have it. As you can see, we have another package here, which I have placed for you already. I have created this package, and I have placed it here for you. For now, I would say that don't worry about this package. I'm only going to tell you that this package contains a custom action message which I have created. Yeah, you can have a look at it if you want later. I'm not going to go into details about it today in this live class because it would be too much. Maybe another day in a different live class we can talk about action message creation, but for today it would be too much. So for now, just keep in mind and remember that inside this package I have created an action. Okay, we are going to see a little bit more about it later, but that's it for now. Okay, so I have created my package. Let's keep going. Then next thing I'm going to do is to actually create my C++ script. So for this, I'm going to go inside my package, which is my action server, and inside the SRC folder, I'm going to create a new file. So I'm going to come here to the SRC folder, right click on it, and this is going to open the menu, and now I can select different options. In this case, I'm going to create a new file, and I'm going to name it as action_server.cpp. There we go. As you can see, this when I create this new file, it automatically opens here in my IDE as an empty file. Here I have it, okay? Let me close this one. So what I'm going to do next is to just copy here from the notebook the code I have placed here. I'm going to just select everything, select the whole code. There we go. I'm going to copy the whole code and paste it here. Oh yeah, if you try to copy and paste it here from by the regular method, which is right click, copy and right click paste, this is going to show you a message here. This is something we have to work on it in order to not have this message. In any case, how you can do it is just select everything and use the shortcut, which is Ctrl+C from your keyboard, and then come here and Ctrl+V, which is basically going to paste all the code here. Okay, so just do it like this. Do it using the shortcut Ctrl+C and Ctrl+V to paste, in order to avoid any kind of issues. Because as you have seen, if you try to do it with the mouse, maybe you are going to get some messages, some error messages. Okay, by the way. Okay, yeah, there we go. Okay, so don't worry, I'm going to come back to this code right now in order to explain it. But, well, no, in fact, let's do it right now. But before going to it, let me have a look at the chat. I can see that you are posting here some messages, so let me have a look at what is going on here. Strange, I do not have the node server diagram in my notebook, says Engineering Nations. So you mean this one? You don't have this diagram? Yeah, that's strange. That's strange. Well, in any case, it's not that important. So yeah, the important thing is that you have all the commands and everything, so that you can follow the live class and copy paste all the commands, the codes and everything. You have to type first this command. I got thanks. Okay. Can we use mkdir command to instead of this? Can we use another command to create our folder? My action server. No. Okay, I get now your question, Morat. So Morat is asking if he can create this my action server package using mkdir. So for those, in case you don't know it, mkdir is a Linux command which allows to create folders. For instance, my folder. Okay, this is going to create here a folder which is named my folder. But this my action server is not a folder. This is not a regular folder. So this is a ROS2 package. So as you can see, when I created my package using this command, the ROS2 package create command, which you have here in the notebook, you have it here. When you create this package, the my action server package with this command, actually you are not creating a regular folder. You are creating a ROS2 package. What does it mean? This means that, as you can see, it is created with things inside it already. It has a cmakelist.txt file, it has a package XML file, so it has some things that we are going to need in order to compile this as a ROS2 package. Okay, so this is very different as creating a regular folder with mkdir, which is actually created empty. Yeah. So no, the answer there is no. You cannot create. Let me remove my folder. By the way, you cannot create the my action server package with mkdir. Okay, this is super important to understand. Okay, I get it. Thanks. Now I understand. Okay, great. It's actually very good that you made this question, because this is a common confusion and a common mistake in people who is starting to learn all this. So it's very good that you made this question because I can clarify for everybody and explain this for everybody. Okay, then okay, so I have created my ROS2 package in my action server, and I have already created my script, my C++ script, and I have copy pasted here the code from the notebook to my actual script here, which is named action_server.cpp. Then let's have a look here at the code and see what's going on here. So this is the code for the action server. Then what do I need to have in the code for my action server? Okay, let's go for the most important parts. First of all, here, as we can see, we have some include, so we are including some modules that we are going to be using in our program. For instance, we are including RCL CPP, of course, in order to be able to create ROS2 programs using C++. Also, we are importing some messages like the twist message, which, as you already know, is used in ROS2, also in ROS1, in order to send velocity commands to the robots. And as you can see, we are also importing here from the test action package that I introduced to you before, we are importing the test message. This is the message that we are going to use for our action, okay? Then, let's keep going. So, first of all, we are defining the class, our class, which is named test action server, which inherits, as you can see, from the node class. Then, first of all, we are going to define here our action, okay? So, first of all, here we are defining the message, as you can see, the test message, okay? We are going to see a little bit more about the test message in a moment, don't worry. For now, just keep in mind that this test here, the one that we are importing here, which is defined in this test action package, this is going to be our action message, okay? For now, just keep that in mind. So we are defining our test, and we are defining the goal handle for our test message. Yeah, this is going to allow us to send goals to our action server, okay? Next, as you can see, we are here defining our action server. Yeah, so let me make this, I don't know if I can do this. Maybe I'm minimizing this. I can make this a bit bigger. Let me do it like this, yeah. Better like this I don't lose anything, and I keep seeing your messages in case you have any doubt. Okay, yeah, so first thing, we create our node, which is named test action server, and as you can see, we create our action here, yeah? Action server, create server, which is going to use the test action message, and I am defining here the name which my action is going to have. In this case, the name of my action is going to be my action, okay? As you can see, we have to bind also the handle goal, handle cancel, and handle accepted. Okay, these are all things related to actions in order to handle the goal, cancel the goal, or accept the goal. Also, here I'm defining my publisher. Yeah, using the create publisher function, I'm defining a topic publisher which is going to publish messages into the command vel topic. It's going to publish twist messages, okay, into this command vel topic. Okay, so what else? Okay, so here I have the handle goal function, which basically I'm just, as you can see, we are just going to directly accept and execute the goal. Yeah, so here we could include some functionalities in order to, for instance, depending on how the goal is, accept it or not. In this case, let's keep it simple. So we are just accepting all the goals and setting them as accept and execute, as you can see. So we are directly accepting all the goals. Here we have the handle cancel function and handle accepted. Yeah, so these are functions that all these functions you can modify them if you want in order to customize how you handle goals. So for instance, you could filter some kind of goals if you don't like them, etc. Okay, in this case we are just accepting all the goals because this is a simple example, but I want to explain this so that you know that this is possible. Okay, then once the goal is accepted, we have the execute function. Okay, then here basically is where we have the core of our program. Okay, then actually here what we are doing is let's try to explain it as simple as possible. So okay, yeah, so first of all we are getting here our goal message, which as you can see we get them using the get goal function. Yeah, so basically here what we are doing is to get the goal from the client and save it in this goal variable. Also, we are defining a new variable for the feedback. As you can see here, we are defining another variable for the message, name it message, sorry, in this case. And also, we are setting variables for the result and for the twist message, which in this case is named move. Okay, so first of all, in this first section, what I'm doing is to define all the variables that I'm going to be working with. Yeah, I have a variable for the goal, another variable for the feedback, which actually is the same as the message. Yeah, these and these are all related, not the same, but they are all related, as you can see. Then I have another variable for the result and another one for move, which is the one that I'm going to use in order to set my twist messages, my velocity messages for the robot. Okay, then here I have the main logic, which basically is a for loop, as you can see, a quite simple for loop. So I am defining a variable here, which is named I, which starts from 1, and I am saying here, hey, while my variable I is lower than the sex variable, seconds, this sex is for seconds variable of my goal, I'm going to do this. Okay, then what is this seconds from the goal? We are going to see it in a moment. Let's go step for step. Okay, so we have there are lots of things here in an action, lots of things to take into account. So right now I want to do a full review of the code, and in a moment when we start testing it, we are going to come back to this code in order to better understand all these small pieces. Okay, so don't worry if right now you don't understand something from this code, because at the end of the live class everything is going to be clearer. Okay, then so we have some seconds here in our goal, and while the variable, our variable is lower than this seconds value, we are going to keep doing this. And what is this? Well, basically in this case, no, sorry, not this. Here in this case we are only checking if we are canceling the goal. So in case we cancel the goal, we send a cancel goal order, then this if is going to be triggered and I'm going to go out of my action. Okay, if I'm not canceling the goal, then this is what is going to happen. So basically I'm setting a linear velocity in the x-axis of 0.3 in order to move my robot forward. Yeah, so I set this velocity, I publish the message, as you can see here, into the command bell topic. I also publish the feedback. And what feedback I am publishing here? As you can see, it's this message here. Yeah, but actually where do I have this? Okay. Yeah, so I am publishing first the command bell message, the twist message to the command bell topic in order to move the robot, and then I am publishing the feedback. Okay, then okay, so then I'm going to check finally if the goal is done, and if the goal is finished, I'm going to set my result. I'm going to also set the velocity back to 0 in order to stop the robot. I'm going to publish this 0 velocity to the command bell topic, and I'm going to set the goal as succeeded. Okay, more or less, do you have a general idea? I know that it's a lot of code, it's not easy to understand. It's also C++, which makes everything more complicated. Morat is asking, excuse me, what do you mean by publishing the code? If you mean this, publish, action that is happening here and also here, by here what I'm doing is to actually publish a message into the command bell topic, okay, in order to move the robot. So this publisher was defined here at the beginning, here, as a topic publisher which is going to publish twist messages into the command bell topic. Okay. Then what is happening here is that I am publishing here a message which is move. You can see the move message. I am defining it here. So I'm publishing this linear velocity into the command bell topic in order to move the robot forward at a velocity of 0.3 meters per second. Here I am doing the same, but I am setting this velocity to 0. So actually what I'm going to do is to stop the robot. So while my action is taking place, my robot is going to be moving forward. But when I finish my action, when my action is done, then I want to stop the robot. That's why I set here the velocity to 0. And this publish, basically it's doing this. It's publishing a message, a twist message into the command bell topic. Okay? Yeah? So just a very quick summary. So we define our action here, which is named my action. We define a publisher, which is going to publish messages into the command bell topic. We have here all the functions in order to handle the goal, handle accepted, handle cancel, and handle goal. And then we have the execute function, which is the main function, and where the functionality of our action is defined, let's say. Then we are defining here all the variables we need. We define the logic of our action, which is that while the variable I is lower than a seconds value, which is defined in our goal, while this happens, I'm going to move the robot forward and I'm going to keep publishing some feedback. Then when the variable A reaches the seconds value, then I'm going to get out of this, I'm going to set my action as finished, and I'm going to stop my robot and send back a result to the client. Okay? Alright, then let's see this in action actually, because this is too much abstract, too much talking about code, which I don't like, but I wanted to just introduce a little bit all this script, which is quite a lot of code. Then right now what we are going to do is to compile our script. Before compiling though, we need to update the CMake list txt file of our package with this snippet of code. Yeah, so you can come here directly and copy and paste this into the CMake lists txt file. Okay, let's come here and I'm going to copy it here at the end of the CMake list file, right above the amend package function. Yes, so if you come here to your package, my action server, you open the CMake list txt file, you come here to the end of the file, let me actually remove it right now, and you are going to see that in the last line you have this amend package function. Then right above this line, I'm going to copy and paste these lines that I have here in the notebook. Okay, let me do it. Then basically here, let me explain it real fast. Basically here what we are doing is to generate an executable, as you can see, from our script. So here we have defined our C++ script, and here what I am doing is to generate an executable from my code. Okay, and I am installing this executable. The executable I'm going to name it test action server. As you can see, this is the name of the executable and this is the name of the script from which I'm going to generate my executable. All right, then let me save this, and now, yes, I'm going to compile my package. In ROS2, in order to compile a package, we use the colcon build command. Okay, then let's come to the source of, to the source of the ROS2 workspace. This is super important. In order to compile, we need to be in the source of our ROS2 workspace. Okay, then let me run here the colcon build command, which is the command used in order to compile a package. And this is going to start to compile. Okay, it's almost there. Okay, it has finished compiling. Then, super important also, after compiling, it's very important to source our ROS2 workspace. Yes, in order to source the ROS2 workspace, we can do it with the following command. Source ROS2 workspace, install folder, and setup.bash. There we go. This is going to make sure that my ROS2 system is going to take the latest changes that I have compiled for my workspace. All right? Okay, then at this point, I am already ready to run my action. I can use the ROS2 run command, specifying the name of my ROS2 package and the name of the executable which I have just generated in compilation. Engineering Nation says, I am getting an error after running colcon build. One package failed, my action server. Okay. Have you updated Engineering Nations? I'm going to call you Engineering because it's shorter. Okay, so Engineering, have you... One package has my action server. Okay, have you added these lines to the cmakelist.txt file? Have you done this? The add executable, amend target dependencies, and install? Have you added all this to the cmakelist.txt file? Yes, no? Yes, I added them to the cmakelist file. Okay, then one thing, maybe it happened. Okay, so I would recommend you to remove remove the code, remove your C++ file, remove everything, and copy and paste again from the notebook. Copy the code again from the notebook here, remove it from your file and paste it again, because maybe you touched, unintentionally you touched something here in the code and changed something here. That's a possibility I can think of, because otherwise it doesn't make any sense to me, because I am compiling it as you can see normally. I didn't get any error or anything, so probably you changed something without knowing here in the code, and that's why it's not compiling. So see, okay, try that engineering. Okay, all right. So after compilation, as you can see, very important to sort the workspace, and now I am ready to execute my action. So I'm going to one more time copy this command from the notebook, Control C, Control V. ROS2 run, I specify the name of my package, my action server, and the name of the executable, which I have created here in the cmakelist file. Yeah? I'm going to run this. Okay, so now I have my action running. Okay? Then how can I interact with my action from the command line? Okay, let's go to the next section, which is section 1.2, get data from the action server. Okay, for this I'm going to open a new web shell by clicking here on the plus button I have. This is going to open another shell. And here I'm going to need one more time to source the ROS Foxy distribution so that I can execute ROS2 Foxy commands. So I'm going to need to source again my shell, and now one of the commands I can use, for instance, is ROS2 Action List. This command is going to show me a list with all the actions that I have running right now. In my case, as you can see, I have only one, which is named my action. Yeah, this action is actually our action that we are running here from the program. Remember, when we defined the action here, we named it my action. So basically here I am seeing this action, the one that I am running in the first shell, this one. Okay, so far so good. So we have our action up and running. Okay, another command I can use is ROS2 Action Info. Then let me run this one, ROS2 Action Info, and I'm going to specify the name of my action. I want to get information about my action. There we go. So this is the name of the action, which is my action, the number of clients, which is 0. So right now I don't have any client for my action, and I have one server. The server is this node, test action server node, which is our node, as you can see. This is the node that we have defined in our program. Okay, so far so good. So we have the action that we have created, which is named my action, and we have one server, which is the program we have created here. And so far we don't have any client for our action, which is true. So we don't have any action. So at this point, basically, we have built half of this diagram. Yeah, we have created the action server, which is this side here. We have the client missing. Okay, let's go step by step. Okay, then another thing that I can do is to execute the ROS2 Action Info command, adding a /t at the end. This is going to tell me the type of message that my action uses. As you can see, my action uses the test message, which is contained inside the test action package. Yeah, you're right. This is the package that we have here. Okay, then a very important thing at this point is to get information about the message. So I need to know more information about the message. Then for this, I can use the ROS2 command, ROS2 interface show. Let me copy this command directly from the notebook and copy it here. So ROS2 interface show and the name of the message I am interested in, which in this case is the test message. This is going to give me information about this test message if I execute it. So let me execute it, and this is complaining that it's not finding the test action package. Okay, that's true. That's true. Can somebody tell me why I'm getting this error? Why it's not finding this here? Why I'm getting this unknown package message? Because the package is here. We can see it. The test action package, we have it here. But it's not finding it. Why? Can somebody tell me in the chat why this is happening? Let's see if somebody comes up with the right answer. Yes, no, yes, no. Does somebody know why I'm getting this error? Or what should I do? No idea for that? No? Okay, so it's related with something. I can see that you are talking there in the chat. It has some relation with a message I can see here from Engineering Nations, which says, maybe try source ROS2 workspace install setup bash. So actually this is what is happening to me. I am not able to find this test action package because I have not sourced the ROS2 workspace, which is the workspace which contains this package. So in order to be able to find this package, I need to source my ROS2 workspace. You see? So now, if I source the ROS2 workspace, install setup.bash file, and I repeat the command ROS2 interface show, now it does find my package. See? So this is why it's so important to always source. Because otherwise your system is not going to be able to find packages. If you don't source your workspace, your system, as you can see, is not going to be able to find the packages. Okay? Okay, so here I can see the structure of my action message, which is named test. Basically, as you can see, it's divided into 3 parts because it is an action message, and actions are made of 3 parts. We have the goal, the feedback, and the result. Then the first part of the message is, which is this one, is the goal. This is the goal. Then the goal for my action message is going to be an integer named secs for seconds. Okay? This is going to be the goal for my action. Then the middle part of the message, which is this one, the status, this is the result for my action. This is the result part of the message, okay? And the final part of the message, which is the one here at the end, is the feedback, okay? So actions and action messages are divided into 3 parts. So we can see here in the graphic, we have the goal part, the feedback part, and the result part, okay? And it's the same for action messages. They are divided always in 3 parts: the goal, the result, and the feedback. Then, as you can see in our test action message, the goal is an integer named seconds, secs, okay? That's why in our code, if we come back to our code, here we are checking inside our goal, we are checking the seconds variable. That's why. Okay, let me see. I can see many messages here. Let me see here. Engineering Nations is having problems. Yes, I added package my action server not found. I forgot to source Foxy in this terminal. Okay, yeah, it's super important to always source Foxy, of course. If you don't source Foxy, you are basically not going to be able to use any ROS2 command. And that, okay? It worked, try to source before building. Okay, so I deduct it has been solved. Okay, great. All right, then, by the way, yeah, so we were talking and getting information about our message. By the way, you can also check the message here directly from the graphical tools. If you go inside the action folder, you are going to see the message file, this test.action. Here we have the message defined. Okay? Just remember this always. Action messages are divided into 3 parts. The goal part of the message, which is the first one, the result part of the message, which is the middle one, and the feedback part of the message, which is the last one. Okay? Alright, then, once we know all the information about our action, we are prepared to send a goal to the action. Okay? Then, here we have the message, the command we can use in order to send a goal to the action server. Okay? Then let me copy and paste it directly here to the web shell, and I'm going to explain it very quickly. So it's super easy. The command is ROS2 Action send goal. Then we specify the name of the action we want to send a goal to, which in this case is my action. We specify the type of message, which we already have identified by getting information in the previous steps about our action. And finally, we define the value. So as you can see here, what we are doing is to assign to the sex value of our goal, we are assigning the number 5. Okay? Remember, this sex that we have here is the goal part of the action message. Alright? So in this case, I am setting this seconds value to 5. So in our logic, in our action logic that we checked before, basically what is going to happen is that my robot is going to move forward for 5 seconds, during 5 seconds. Okay? Then after these 5 seconds pass, it's going to stop. Okay? So this is the very simple idea. The very simple logic behind this action server. Yeah, this is just an example, so I wanted to build something which is as simple as possible. Alright? Then, okay, so yeah, if I send this goal, what is going to happen is that the robot should start moving forward for 5 seconds. Okay? Then let me do this. Let me send the goal and see what happens here. So the robot starts moving forward, as we can see, and it stops. Okay? At the first time it's gonna move 5 seconds, and on the second time, how much? The same. If I run it again, it's going to do exactly the same. And if I put 10, for instance, let me put a 10, you can change in the command the value you assign to the seconds variable. So in this case here, you can see that I put 10, and then it's going to move more time for 10 seconds. There it goes, it keeps moving. As you can see, it takes longer in this case, and after 10 seconds it stops. Okay? Then, yeah, so more or less we have covered everything, but there is one last thing, because I cannot see any feedback here, right? So I have sent the goal accepted, as you can see here. We have the result when the action finishes, and the result is telling me finished action server, robot moving during 5 seconds. Okay, but what about the feedback? We don't see the feedback anywhere here. Okay, then in order to activate the feedback, we need to specifically indicate it when we are sending the goal to our action server. Okay, by adding this, as you can see here. Okay, so let me clear this, make it a bit bigger. Let me get closer to the robot. There we go. Okay, so if we want to activate the feedback, we need to specify it here by adding / feedback. Okay, then if I activate this option, now let me run one more time the action. As you can see, now I receive the feedback. Okay, there we go. So we set the goal, as you can see, the three most important steps here when working with an action. In order to try to summarize all this, the first step is to send the goal from the client, which the client in this case are us. We are creating a client by executing this command, yeah, by sending a goal. Then the first step is to send the goal. Let's go back here to our graph. So from the client that we have created, we are sending the goal, which travels to the action server. Then once it is in the action server, it's going to do whatever it has to do, whatever it is defined inside the execute function of the action server. Okay? Then while the action server is taking place, in this case, in our case, the robot is moving forward, I keep receiving the feedback, as you can see. And at the end, when the action finishes, I get the result. I receive the result from the server to the client. All right, as we can see here. Yeah, so I send the goal from the client to the server. Meanwhile, the server is executing. I keep sending feedback back to the client so that the client has some information of how things are going. And when I finish my action, I send the result back to the client. Yeah, makes sense? Okay, yeah, so basically that's it for today's live class. We are 20 minutes already past the time. We should have finished it at 20 minutes ago. However, since I took some more time at the beginning in order to explain all the system, I wanted to finish this live class and try to finish all this. So yeah, that's basically it. You can keep practicing now if you want with the action and testing different things with more time and at your own pace. But for me, I'm going to leave it here. Let me know, do you have any doubt here? Let me check the chat to see if there is any final question before I close. Let me have a quick look here at the chat. Did your package finish building properly after running Qualcomm build? Okay, I think you are talking between you guys here. So does it make sense? Do you get more or less a general idea? All things is good for me. Thanks, master. You're very welcome, Morat. Very welcome. You're welcome. No problem at all. Yes, it did. Okay, so in case you are, some of you are getting some kind of error, just make sure that you follow all the steps as indicated here, okay? Make sure, check all the steps, check everything, because all of us, me and all of you, we all have the same environment, okay? So we all have the same project, we all have the same files, we all have the same everything, okay? So if it compiled, let me close this, by the way, let me stop my action now. So if it compiled for me, it has to compile for all of you, okay? Because we all have the same code. If it's not compiling for some of you, make sure that you haven't changed anything in the code, or you have something different here in the CMake list. Check all of this and make sure to follow the indications here of the notebook, okay? Okay, so I see that you keep talking here. All things. So I'm going to leave it here. Thank you very much for the live class. I hope you enjoy it. I hope you you got something from this hour and 20 minutes that it has lasted this live class. It's a little bit more than usual. Let me in fact change to my screen right now. So yeah, thank you very much. I hope you have enjoyed this live class. I hope especially that you have liked the new environment where we have integrated everything, the project screen with the live class stream, with the chat, everything in one single place. I think it's great, and it's going to allow us to be more connected, let's say, and it's going to also help everybody in the process of testing and doing things while you pay attention to the live class. So it's now easier to follow the live class and to see what I am doing at the same time that you are doing also all the steps described in the notebook, creating the packages, creating the codes, etc., etc. So I think everything is much more integrated now, and this is going to help all of us to keep progressing in these live classes and to keep learning together. So yeah, thank you very much all of you for being here today. I'm going to see you next Tuesday for next live class, and as always, until then, take care and keep pushing your ROS learning. Bye bye. What are you doing, Alberto?
I'm training this intern with ROS.
Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises, a fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects. Want to become a happy Alberto? Request a demo today.